Want to ace your Java interview? Multithreading is where most developers struggle. But don't worry. Today, we'll go through the most frequently asked multithreading questions, break them down, and write code together. And by the end, you'll have a clear roadmap to mastering Java concurrency. Ready? Let's dive in. Let's start with a classic question. What's the difference between Runnable and Callable? Both are used to create threads, but there's a key difference. Runnable doesn't return a result and can't throw checked exceptions. Callable can return a result and can throw checked exceptions. If you see the method signature of run method in Runnable, its return type is void, which means it does not return any value. Also, it is not throwing any exceptions. And if you see the method signature of call method in Callable, it does return a value. Also, it declares to throw exception. This means that you can throw subclasses of exception, which are checked exceptions. So, if you need to get results from a thread, Callable is the way to go. Next question is, synchronized versus lock, which one should you use? Both synchronized and lock prevent multiple threads from accessing the same resource, but which one is better? Synchronized is simple and automatic, but it can't be unlocked manually. Lock gives more flexibility and control. It can try locking, timeout, and unlock manually. Use synchronized for simple cases, but if you need more control, lock is a better choice. Next question is, how to avoid deadlocks? Deadlocks happen when two or more threads wait forever, because they hold locks that the other thread needs. If you see this code, it has two threads, trying to acquire locks for same two resources. In this example, thread 1 takes lock of resource 1, then waits for resource 2. Thread 2 locks resource 2, then waits for resource 1. Since both threads are waiting for each other, they will never proceed. This is deadlock. Now, in order to avoid deadlock, first approach is to acquire locks in the same order. This is the corrected code. Now, both threads always lock resource 1 first, then lock resource 2. No thread will hold one lock, while waiting for another in reverse order. This prevents circular waiting, which is the root cause of deadlocks. Another approach is to use lock interface, instead of synchronized, to prevent access to a shared resource by multiple threads. With try-lock method, even if the thread is not able to acquire lock, it will return after the specified time, and the deadlock will never happen. When multiple threads work together, sometimes one thread must wait for another to complete a task before continuing execution. For example, imagine a producer-consumer scenario. Producer generates items and notifies the consumer when they are ready. Consumer waits for items and processes them once available. In Java, thread communication is handled using wait, which makes a thread pause execution until another thread notifies it. Notify, which wakes up one waiting thread so it can continue execution. Notify all, which wakes up all waiting threads on the same object. A ThreadLocal variable is a special type of variable where each thread gets its own isolated copy of the variable instead of sharing it. You can create a ThreadLocal variable of any type using its constructor, and then set its value in a thread with its set method. To retrieve the value of ThreadLocal variable, use its get method. Its value will be the one set in each thread, and it will be specific to that thread only. A ThreadLocal variable is very useful for maintaining thread safety without synchronization. Many developers initially think of extending thread or implementing Runnable, but these approaches aren't the best for real-world applications. Because manually creating threads can consume too many system resources. There's no built-in control over the number of threads, which can lead to performance issues. Managing thread lifecycles manually is complex and error-prone. The best way to create and manage threads in Java is using executor service with a thread pool. You can create an executor service with static methods available in executors class. There is a method newFixedThreadPool, which creates a thread pool with a fixed number of threads. This number is provided as a parameter to newFixedThreadPool method. Once we have an executor service, we can use its execute method and supply it the task to execute as a runnable object. Executor service will itself manage the creation, task execution, and management of threads in the pool. Threads will always remain in the pool, and executor service will be responsible for assigning tasks to those threads. There is a dedicated video on executor service, its link is at the top right. You can watch it for better understanding. After all the tasks are completed, you can terminate all the threads with shutdown method of executor service. So, if you need multiple threads, always use executor service instead of manually managing them. It's the best practice in modern Java applications. This is a very common question where many developers get confused. Sleep causes the thread to pause for a specified time. Wait makes a thread wait indefinitely until another thread calls notify or notify all. Sleep does not release the lock if inside a synchronized block. Wait releases the lock so other threads can access the object. With sleep, the thread continues execution after the time expires. With wait, the thread will not resume until notify or notify all is called on same shared object. Also, sleep method is written inside thread class. Wait method is written in object class. Finally, sleep is a static method. Wait, on the other hand, is a non-static method. That's it for today. We covered some of the most important multi-threading questions, along with code examples. If you found this useful, hit the like button and subscribe for more Java content. And don't forget to comment your favorite question.